Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad ARIS bin AZMI and I am from group 4. Our group choose total acid number, which is ton, as our topic. Today I will explain about the introduction and justification of solution part. Okay, in the poster we can read the introduction part, which is ton is the measure of acid concentration in a non-aqueous solution. It is determined by the amount of potassium hydroxide KOH required to neutralize the acid in 1 gram of oil sample. Total acid number ton test also is one of the method that nowadays used in the oil analysis field in order to estimate the amount of additive depletion, acidic contamination and oxidation. Besides, ton does not represent the absolute acid concentration of the oil sample. Ton measurement detect both weak organic acids and strong inorganic acids. Okay, what is meant by the introduction part is total acid number process is a measurement of acid concentration. In a aqueous solution it does not involve with water. It uses oil as its sample solution, and then it use alkaline solutions, which is potassium hydroxide, to neutralize the acids in the oil sample. The oil sample volume is 1 gram. Ton also can differ which organic and inorganic compound that has strong acidic properties or does not have strong acidic properties. Okay, next is I will explain about the justification of solution, which is the objective of the of this topic. The first one is to understand the role of acid number as tool to monitor machinery condition. Okay, what is meant by the first objective is we can know the function of acid number as a medium, as a tool to see how the process change, how the process occur when the potassium hydroxide is been poured in the oil sample. We can see how the oil change from become the acidic oil solution to become neutralized oil solution or oil sample. Then the number 2 is to analyze the source of acid number change of oil sample, which mean we can determine the causes of how acid number change in the oil sample. Next is I will pass to my colleagues. That's all from me. Thank you.
Hi everyone, my name is Franklin. So I'm going to talk about discussion of the total acid number. So acid number results are used as a guide in the quality control of lubricating oils. The rate of change of the acid number is more important than its absolute value. A rapid increase can be caused by many factors, including excessive degradation due to hotspot from dirty oil waste, top up with different oil, or a changed fuel sulfur content. More commonly, a steady increase in acid number may be caused by oxidation over time or temperature effect. High operating temperature can generate increased level of weak organic acid. Oils with high acid number will form undesirable gums and lacquer on metal surface. High acid number are also associated with increased viscosity of pumping losses and system corrosion, especially in the presence of water. A combination of compounds with a wide variety of corrosion properties contribute to the acid number. Therefore, this test cannot be used to predict the corrosiveness of oil being used under service condition. There is also no establish link between acid number and the corrosion activity of oils toward metals, although acid number value are often used as a measure lubricant degradation in service. Any limit must be manually established for the particular type of sample that is being analyzed. Extremely dirty, thick or contaminant sample may require an interesting volume of solvent, increase stirring to dissolve the sample, or increase rinse time. This will help to keep the electrode in a clean and consistent working state to ensure reliable end product result. Otherwise, the electrode can become coated or contaminated and the result will steadily deteriorate or incorrectly obtained. As extra static rinse can also be added if necessary. Manual cleaning after dirty sample must be done with care, particularly to minimize contact with the sensing element surface on the pH electrode bulb. Automated solvent addition and extraction is highly recommendable for this method. This eliminates the need for laboratory technicians to handle solvent for every sample and reduce the amount of solvent available to evaporate the cause health concern. This also enables the system to run completely unattended, allowing laboratory staff more time for other effort. An extended range is available if the sample size or titrate concentration is adjusted. A reduced size sample will enable the user to accurately measure high acid number. A reduced titrate concentration will enable the user to measure extremely low acid number value. So that's all from me.
Hello, Assalamualaikum. My name is Muhamad ZULHILMI bin RAZALI. Okay, now time is my part. Okay, I will explain to you about the result. Okay, just now you see, you can hear or you can listen about my friend's presentation at the introduction, at the methodology, at the justification of the solution. Okay, now it's my part. It's about result. Okay, so I start my presentation about you can see 0.1 of KOH value. Okay, so in this experiment we use 0.1 KOH value. Okay, so then after that you can see we have a three sample that we use, which is blank B, sample 1 and sample 2. Okay, these three sample we take their weight, and you can see at the start level their weight already different, which is black B start with 70.2. Okay, then followed by sample 1 weight is 17.5, then sample 2 weight is 27.4. Then we go through to the end level. At the end level we take another 1 times weight. So at the blank B is 17.5. Okay, 70.5. Then after that sample 1 is 19.0, then third one is 27.9. Okay, so after that we go to total consume. Total consume is end level minus third level. As example at blank B, okay, we stay at 17.5 ml minus 17.2 ml, which is we got 0.3. Okay, so go on with sample 1 also same, 19.0 minus 17.5, we got 1.5, and sample 2 27.9 minus 27.4, we got 0.5. Okay, so then we go through to the total acid number. Okay, for total acid number, okay, for sample 1 we got 3.3666 times 10 minus negative power of negative 3. Okay, then for the sample 2 we got 0.561 times 10 minus negative 3. Okay, for total acid number, how we get it? Okay, so we get it from the calculation is blank B is 0.3, is it? Okay, the total consume, so 0.3 will divide by 1 times 10 power of 3. Okay, then we got 0.003 liter. Okay, for this 0.003 liter, okay, for the blank B. Okay, so For the simple one, we have 1.5 ml, right? Also same, we minus with times time 1 times 10 power of 3. So then we got the answer. Then the answer will minus with 0.00 t at the blank b just now, times 0.1 times 556.1 by divide by 2. Then we got the answer. That's how we calculate it. Okay, so this only for my part, so we continue with my friend part. Okay, thank you.
Assalamualaikum, I am Muhamad Rhosul. I will explaining on the methodology of total acid number analysis in oil and wear debris analysis. So the first things to do is to prepare titrant solution of 0.1 mole. So titrant is being prepared by firstly add 5.611 grams of gallium hydroxide or KOH2 1 liter isopropanol. Once completed, transfer carefully the titrant into the 50 ml glass burette. Then titration solvent 1 liter is prepared by mixing 5 ml deionized water, 495 ml isopropanol and 500 ml toluene. Then perform blind titration to identify total acid number in the titration solvent. To perform this blind titration, 100 ml of titration solvent poured into 250 ml aluminum flask. Then, during dropping process, 10 drop of phenolphthalein is added. The solvent then titrate against titrant. Shaking process. This involves the shake process of solvent continuously until the end point where the solvent start to change to pink color. When solvent has permanently turned to pink color, that is the end point. The value of titrant consumed is recorded in table 2. For sample titration of 100 ml of titration solvent poured into a 250 ml aluminum flask. Then the titration solvent was weighed on electronic mass balance and was set 0. Introduce first sample, which is used gearbox oil of 2 gram into the titration solvent. 10 drop of phenolphthalein added into the mixture of sample A and titration solvent. Shake the mixture of sample A well before placed under burette. The mixture of sample A is titrated against titrant while the flask being shaken vigorously. Titration process stops when the solvent turns to pink color. The value of titrant consumed recorded in table 2. For sample B of 2 gram of used hydraulic oil, the same step in procedure for sample A of used gearbox oil is repeated until the solvent turns to pink color. Then the value of titrant consumed is recorded. Thank you very much.